Okay, so the first thing we're asked to do is find the transfer function, which I did right here. Sorry, right there. It's in standard form. And then you use the equations that we were given in recitation to find all the variables that go into it. And then plugging in all those variables using the TF, built-in TF function in MATLAB, you get this to be that's your transfer function with all the variables in. So then I made a Bode plot of that, and it looks like this. So the green one is has the resistance that I solved for in it, and then the red one is that resistance times 100. And you can see they go to the same magnitude, but they get there in a different way. And then for the phase change, the one that I solved for goes to a corner and goes straight down, and the other one, it begins to change phase earlier on. And also this frequency here, this peak, is 89.7 megahertz, which is the frequency that we solved it for, so that makes sense. It's in radians per second down here, but you have to multiply that by 2 pi to get hertz. Okay, next we went to the high pass and low pass filters. So, okay, here's what I got for my low pass filter. Sets of variables already solved for. I used the same variables as before, and then here's the high pass. So I plotted those, and it looks like this. I think it's bigger. Okay, so for the magnitudes, okay, so let me think how this works. So they end up having the same, like once a long time has passed, they reach the same place, but they go there at different speeds. It's the same as last time. The one with the higher resistance got there quicker. So this is a low pass here, and that's a high pass. And then for the phase, a low pass has a negative phase, and a high pass has a positive phase. So that's the main difference between the two of those. There's one more thing I missed earlier. It asked us to check to see if our function is stable or not. Or this is in part 1. So what you do for that is you solve using the quadratic formula. You solve for s, and you take the real part, and if the real part is negative, then it is stable, and my real part is negative. So I'm going to say that my function is stable. Thanks.